Alrighty, so in example 4, we're using case 2. The reason why that is because our denominator is a product of linear factors that also repeat. So we actually have 3 of them, right? So it's repeated 3 times. So we are going to be using the second one right here, okay, where we write the linear expression. We first start with the first power and then go to the second power, and we just go up to whatever power it is, and then we just add a, b, c, d, and so forth, okay? So we have x plus 1 to the first, to the second, to the third, a, b, c, okay? And then we do the same thing that we've been doing previously. This one, so our goal is to have everything to the third power. So a is missing 2 of them, b is missing 1 of them, and c is missing none of them, okay? Now from here we can do some algebra. We can FOIL this out, get this. To get rid of parentheses, we can distribute that a everywhere, and we can distribute this positive b everywhere, okay? And now this is really cool math. Well, I think, I don't know. Okay, so essentially we have second power, we have the first power, and then we have just numbers. So what we can do is write out this x squared in descending order. So we have x squared, and then we have 0x, and then we have plus 0, and then we have all this stuff we just found on the right hand side, okay? So what we're going to do is combine all of our squareds into 1. So when we combine our squareds into 1, we get this. Those x squareds will cancel out, and we're left with a equal to 1. Now we do the same thing for our x's, which I've highlighted in red. We combine all that stuff. Those x's will all go away. And then we can solve, and we already know that a is 1, and we find that b is -2, okay? And then we do the same thing with just our numbers, and we plug in for our a and b that we found, and we found c is 1. So now we go back over here to our right hand side, we plug in our new a, b, and c. Remember that this now is negative, and then we go from there, okay? This is a little bit different from the other problems that we worked because now we have a power on the bottom, so we are going to use u substitution to make it easier for us. So we're going to let u be the stuff on the inside. You remember talking about that, okay? So we're going to let u be x plus 1. So I let u be equal to x plus 1, which means du is just dx. Okay, so now if we do that for all of these, we have this right here. And then we can easily rewrite these as negative exponents, right? I left this one on the bottom because we already know that we can use our natural log absolute value trick, right? So if it's on the bottom and there isn't a power, we can use the natural log absolute value trick. If it's on the bottom but there is a power, we need to be able to bring it to the top so we can do add 1 divided by that number, okay? So now, for this first one, the derivative of the bottom, the derivative of u is 1, so that means we just have natural log absolute value of the bottom, okay? Over here, we add 1, which gives us -1. So we're going to raise it to the -1, and then we're going to divide by -1, which is going to make it +2, okay? Over here, we add 1, which is going to raise it to the -2, and then we're going to divide by -2, okay? Which is why we have -½ here. And then we do our plus c because we're not evaluating it from anything. Initially, we were looking for the integral with respect to x, so we have to go back and plug in what u used to be. U used to be x plus 1, so we just make sure that we change all of our u's back to x plus 1. Because this is negative, I just moved it to the bottom, but that's not necessary, but it just looks nicer.